viewers to another episode on your G12 exams. So in this episode we continue looking at the 2019 Science Paper 1, which is basically physics. So we are looking at section B, which carries 45 marks and has 9 questions which are compulsory. So let us start by looking at question B1. Figure B1.1 is a graph showing how the velocity of a car changed when the driver applied brakes upon seeing a head of cattle crossing the road ahead. Use the information on the graph to calculate the acceleration of the car between points A and B. So between A and B, what you notice here is at A, the velocity or speed is 12 meters per second, then it's reducing to 2 meters per second. Then we know that acceleration is equal to basically change in velocity, final velocity minus initial velocity over change in time. So our initial velocity basically is 12, then the final is 2, so it will be 2 minus 12 over what's the change in time. So this is 0, then at this point this is halfway, which is basically 5. So 5 minus 0 is just basically 5. So we say 5 minus 0, we have 2 minus 12, which is negative 10 over 5. So 5 into 10 is basically negative 2. So since it's deceleration, so it's 2 meters per second square, because it's already deceleration, so it's basically, you write it as a positive number. If you write as acceleration equal to negative 2 meters per second, it means it's deceleration. Then B, distance moved by the car in the 10 seconds. So if you notice here is basically 10 seconds is up to here. So what you need to do is we need to find this area. So we have two shapes which we call, this is a triangle, then this is a rectangle, which is this one. So at distance basically just the area under this curve. So basically we find the area of the triangle. Triangle is half times, so the height is basically this, which is 12 minus 2, which is 10. Then at the length, which is up to here, so this is basically 5. So what we have is basically 10 multiplied by 5, and then plus, then we have a rectangle, this rectangle. So from here to here is basically, this is 10, then the height is 2. So it's basically 2 times 10. Then what we have is basically 2 and 5. 2 into 10 is 5. Then 5 times 5 we get a 25. So this is basically 25. Then plus, then we have this part, which is 2 times 10, which is basically 20. Then we add the 2, we end up with basically 45. So 45 meters is the distance covered. Then next is average speed of the car. So average speed basically will be just total distance divided by total time. So in this case total distance is 45, then time is 10 seconds, so we divide by 10. Then we are going to end up with 4.5 meters per second, which is basically our answer here. So basically this is how you get the 6 marks here on question B. Let us look at B2. Figure B2.1 shows a device designed to compress crushed material for school science project. State one condition necessary for a body to maintain equilibrium. So for the body to maintain equilibrium, so the condition that need to be met is basically the fact that the clockwise, so the clockwise turning effect must be equal the anti-clockwise turning effect. When these two are equal, then the body will be basically in equilibrium. Turning effect. So once these two are equal, what we are going to have? We are going to have 0 net moment. So the net moment will be 0, so meaning there will be no need to swing anywhere because the net resultant moment will be 0. Then let us look at B. Calculate the moment of the 50 Newton force about the hinge. So this hinge is basically the turning point, which is basically the pivot. So remember, moment is given by force in newtons multiplied by distance in meters. This distance should be perpendicular to the pivot. So from the pivot, this is the distance, which is basically 65 centimeter, which is 10 plus 55, which is 65 centimeter. Now this centimeter should be converted to meters. Remember, distance is in meters. Now in 1 meter we have 100 centimeter. So to find this in meters, we just divide by 65, we divide by 100, we end up with 0.65 meters. Then hence we have 50 Newton, which is this one from the pivot. Then the distance from the pivot, which is 0.65. When we multiply these two, we are basically going to end up with basically just 32.5 Newton as our answer. C. Calculate the upward force F which the crushed material exerts on the piston to keep the beam in equilibrium. So we have two forces. This force is pushing downward, this one is pushing upwards. So once these two are equal, like we said in question A, then it will be in equilibrium. So let us call this F to be F2, this F2. Then this distance from the hinge, which is the pivot, which is 10 centimeter converted to meters. Remember, we divide by 100 is 0.1 meter, and this will be distance 2. Then this will be distance 1. Then this will be F2. So if this has to be in equilibrium, A must be true. So what it means is F1 multiplied by distance 1 is equal to F2 multiplied by distance 2. Then we already found this. This is basically this, because this is B. So we have 32 without wasting much time is equal to, when we replace F2 multiplied by the distance is 0.1 meter. So this tells us basically 32.5, which is nothing but this distance multiplied by the force is equal to 0.1 F2 when we multiply these two. Then to find F2, we divide by 0.1, this side 0.1, then this one and this one cancel, so meaning F2 is equal to basically 0.1 into 32.5 is 325 Newton. So here this F is basically 325 Newton. So basically this is how you get the 5 marks on question B2. Let us look at question B3. So B3 reads, figure B3.1 shows some energy conversions in a core powered station. So we have the core, then we have the boiler, turbine, generator, then we have the cooling tower, then we have the transformer. So question A, how much useful electrical energy is provided by the power station? So the use of energy is basically the one which is being basically supplied, which is basically the 300 joule electricity. So basically this one is just that one. So we are starting with 1000, then we are this is what is being supplied to the households or the industries. So we have basically 300 joules as the useful energy. Then let us go to question B. So B, calculate how much energy is wasted from the cooling tower. So if you see, basically let me just go back, the bigger one. So we want the energy wasted on the cooling tower, which is this energy. So we know we are starting with 1000, then what we are ending up with, the useful is 300 joules. Then we know that at the boiler turbine generator we are wasting 70 joules, then at the transformer we are wasting 30. So what this tells us is if you start adding, which is 70 wasted at the boiler, then plus this one wasted at the cooling, we shall call x plus the one wasted at the transformer, which is 30 joules, then plus the useful energy. This must add up to 1000 joule, which is at the core. Then when we add 70 plus 30, which is 100, plus 300 is 400, so x plus 400 is equal to basically 1000. Then x is equal to 1000, we take away 400, so x is equal to basically 600 joules. So 600 joules is wasted at the cooling tower. So hence here basically we have 600 joules. Then C, calculate the efficiency of the power station in the production of electrical energy. So basically efficiency will be basically the output divided by the input. Okay, then you multiply by 100%. So in this case, therefore, efficiency will be, so what's the useful energy? Useful energy is 300. What energy do you start with, which is input from the coil, is 1000. Then we multiply by 100%. Then that and that, then that and that. Then we know 10 into 30 is 0.3 multiplied by 100%. This is 30%. So 30% is the efficiency of this power station in the production of electrical energy. So basically this is how you get the 5 marks on question B3. Let us look at question B4. Figure B4.1 shows a cylinder containing a gas of volume 5 centimeter cubic at a pressure of 100 kilopascals. The piston is pushed to half the original volume at the same temperature as shown in figure B4.2. Question A, state Bohr's law. So Bohr's law states that basically pressure, so pressure is inversely proportional to the volume at a fixed mass of what? Of gas and constant temperature. So as long as the temperature and the mass remain the same, if we reduce the volume, the pressure increases. If we increase the volume, the pressure reduces. That's what the law states. So basically, generally, pressure 1 multiplied by volume 1 is equal to basically pressure 2 multiplied by volume 2. Okay, so because these two are constant, so what it means is from pressure multiplied by volume is equal to constant K. So what this tells us basically is if we increase pressure, we need to reduce volume to maintain the constant K. Then these two gives us this combined principle, where if we increase change pressure from 1 to pressure 2, then we need also to change volume in such a way that when we multiply pressure multiplied by volume is equal to pressure 2 multiplied by volume 2. So basically that's what this tells us. So in short, pressure times volume is equal to constant K. If you can remember this formula, then you can state this one. So we are adding the volume of gas or the mass of gas, constant, and the temperature. Let us look at question B. So B reads, calculate the gas pressure in cylinder in figure B 4.2. So to find the pressure, we are basically use this same principle, that this same extended formula from this. So basically we know volume, this is volume 1, then we know pressure 1, P1, then we are told that the volume, when the piston is pushed, the volume is aft, so this is volume 2. Then the question is asking us to find the pressure, which is P2. So using this one, we know that in this case, we know that volume 1 is that, then pressure 1 is 100 kilo Pascal, so just hit 100, then multiply by, so this is the case, so 100 multiplied by volume is basically 5 centimeter per cube is equal to, so what is the pressure? So we are looking for pressure 2, then multiply by, now this volume is half of the original, so half of 5 divided by 2 would remain with 2.5 centimeter cubic, so multiply by 2.5 centimeter cubic, then we have 500 is equal to 2.5 pressure, then we divide by 2.5, then we divide by 2.5, so P2 is equal to basically 200 kilopascals. So this is basically 200 kilopascals. So without even converting the volume to meter cubic, unless we are given pressure in newtons per meter square, then we needed to have volume in meters cubic. But since it's in pascals, we can just work out it direct. Nothing will affect the results. Use the kinetic energy theory to explain why pressure increases in the cylinder as the volume decreases. So that's C. So basically what you notice here is what happens is gas molecules will be basically in this case left with less space. So once the piston is pushed in, what will happen here is this space reduces from this space. So as the space reduces, remember, as the space reduces, basically they will start colliding with each other more often and also against the wall repeatedly. So because of that, the pressure increases. So basically we are saying this is because the gas molecules basically are left with less space, so the space will reduce, less space, thus they start colliding, so colliding with each other repeatedly. So repeatedly, so with each other and with each other we add the was, so with each other and the was, forgot the was, are repeatedly. So because of that, this increases the pressure. So the pressure, remember, the pressure basically is increases with more corrosion. So because since they are colliding against and each other more often, there is pressure to expand. There is more push to expand, so there is a force exerted on the surface area, hence the pressure goes up. So basically this is how you get the 5 marks. Let us look at question B5. The human audible frequency range is 20 Hz to 20,000 Hz. Taking the speed of sound in air as 330 meters per second, what is the upper limit of the human audible frequency in kilohertz? Kilohertz. So basically, this is a giveaway question. So what you notice in this case is the upper range is basically the 20,000. So how many A's are in a kilo? S is basically 1,000. So basically, if 1 kilo S is equal to 1,000 S, then what we want is, what is X in, then we have 20 S. So we need to convert that. So this we close. This tells us 1,000 X is equal to basically 20,000. Then we divide by 1,000. Then we are going to end up with basically a 20 kilo Hz as our answer. So it's just 20 kilo Hz. That's how we get that 1 mark. What is the wavelength of the lower limit of the audible frequency range? So basically, we were looking for the wavelength of the lower limit. So remember, velocity is equal to wavelength multiplied by frequency. So the lower audible frequency is 20 Hz. Then wavelength is what we are looking for. Then we are told speed is 330 meters. So let us find wavelength. We divide by f both sides. So wavelength is equal to basically velocity over frequency. Therefore, from here, wavelength will be basically velocity is 330 divided by basically 20. So when you divide by 20, that we end up with 16.5 meters. So 16.5 meters is basically the wavelength. Let us look at question B. Figure B5.1 is a diagram of a wave traveling through air. Which labeled distance represents A, 1 wavelength, 2 the amplitude. So the wavelength is basically, we are saying the distance between one either trough or crest to another crest. So if we are to look at this one, this from here to here is 1 wavelength. Okay, then similarly it would be from the crest to here. You've seen this? Here to here, or here to here. That would be a wavelength. So in this case, you know that from here to here, this is basically half, then complete half. So you see W. So W is the wavelength. Then amplitude is the highest distance, which is from here to here, from the 0 to the highest point here. So basically in this case, what is corresponding is here to here, which is X. So X is the amplitude of the wave. So basically this is how you get the 5 marks. Let us look at question B6. Figure B6.1 is a diagram showing the appearance of a coin immersed in water when viewed from above. Question A, state Snell's law. So basically, Snell's law basically states that for the pair of two media, the sine of angle of incidence to the angle to the sine of angle of refraction is constant. That's what it states. Now remember, the angle of incidence is the angle between the incidence layer and the normal. Then refracted angle is the angle between the refracted layer and the normal. Let us look at B. What happens to the rays of light at the surface of water in figure B 6.1 above? Now, since the ray of light is coming from the bottom, as you see, it's coming from the bottom. So what happens is, basically, as it reaches basically the surface is refracted away from the normal, because the air is less denser than water. So they are refracted away from the normal line, which is this one. So remember, if the right rays are coming from the less denser to a more denser, they are refracted towards the norm. If they are coming from the denser to less denser, they are refracted away from the normal. Number C, calculate the refractive index of water. The refractive index of water. So in this case, we are given the real distance and the apparent distance, because the coin is here but it's appearing as if it's in here because of refraction. So in this case, refraction is given by real distance divided by apparent distance. So real distance is 15 centimeter divided by apparent, which is 11.28. You end up with basically 1.3297. Use a calculator. To two decimal places is 1.33 as our reflective index of water based on the data that will be given. So basically, this is how you answer these questions to get the optimal 4 marks. Let us look at question B7. So B7 reads, figure B7.1 is a circuit diagram with two resistors connected to a 3-volt power supply. Identify the type of a circuit arrangement of the resistors shown in the circuit above. So what we notice here is, if one of these resistor is fault, the entire circuit will be off. So even the other one will not receive potential difference of power. Hence, this kind of a circuit is known as a series. So it's a series circuit. Number B, calculate the total resistance in the circuit. So the total resistance in the circuit, so in the series, total resistance is just given by addition of the resistor of each individual series. Then if it was a parallel, which would have looked like this parallel circuit, so we're going to have this is a parallel, whereby even if these two are off, one would still work because potential difference could go through this line. Then total resistor would be basically equal to R1 multiplied by R2 over R1 plus R2. If there are 3, you multiply 3, then you divide by the summation of 3. So this is for parallel, remember, then this is for series. So since this is a series circuit, we are going to use the first one as the formula we use to find the total resistance. So basically R will be equal to, in this case R will be equal to basically 2 plus 2, which is basically equal to 4 ohms. So 4 ohms is basically the total resistor. Let us go to the next question, which is C. Calculate the ammeter reading when the switch is closed. So the ammeter reading will be able to read the current flowing this circuit. So basically you know that voltage, basically voltage is equal to current multiplied by resistor. Since we know the total resistor, to find to find the current, we divide by resistor both sides. So current is equal to basically voltage times divided by resistor. So voltage is basically 3, then we divide by resistor, which is 4. Then once we divide, we end up with basically 0.75 amps. So the reading here will be basically 0.75 amps as our answer. So basically this is how you get the 4 marks. Let us look at question B8. A cell phone charger has a transformer with 2000 turns in the primary coil, which converts 240 volts AC to 6 volt AC, and the rectifier that converts 6 volts AC to 6 volt DC. What do the letters AC and DC stand for? So AC basically is alternating current. Then DC is basically direct current. Then let us look at B. How many turns are in the secondary coil of the transformer? So basically we know the relationship between these two. We know that the number of turns in the primary coil divided by the voltage in the primary coil must is equal to the number of turns in the secondary coil divided by the voltage in the secondary coil. Then from the data that we've been given, we have basically a cell phone charger as a transformer with 2000 turns in the primary core. So number of turns in the primary core is basically 2000, which converts 240. So voltage in the primary is 240 to 6 volts. So voltage in the secondary is 6 volts, and the rectifier that converts 6 volts to 6 volt DC. And the question is asking us to find the number of turns in the secondary. So we are looking for this which we don't know. So using this formula, we can write now as 2000 over voltage, which is 240, is equal to basically X, which we don't know, which we are looking for, this one, over 6 volts. Then what we do is at this point we just do cross multiply. So we end up with basically 240 X is equal to 2000 multiplied by 6. We divide by 240, so X is equal to 0 and 0, then 6 into 6 is 1, 6 into 24 is basically 4 into 200 is 50. So the number of turns in the secondary coil is basically 50 turns. So there are 50 turns in the secondary coil. Number C, draw a labeled diagram of a step-down transformer. So what we need is basically we need the inner, then like this, then we need the coils. So these will be coils, and these coils will be a lot this side, then here there will be just a few of them, but here there will be a lot. So then we are going to have the voltage in this case entering, then like this. Then in this case the voltage is 240, so of 240 the voltage entering here. Then the voltage which is coming out from here, this is basically 6 volts. So this is the secondary coil, then this is basically the primary coil. So this is when we're talking about that there are 2000 from this example, then these are just 50. So basically this is the case of the step down transformer. Then we are told this is AC. Remember, the transformer works with AC voltage. Okay, so basically this is how you get the 6 marks on this question. Let us look at question B9. The symbol U with superscript 238 and subscript 92 represents a nucleus of uranium with the nucleon number 238 and proton number 92. Question A, state the meaning of nucleon number. So nucleon number basically is also known as mass number. So once you know that it's basically easy. So basically this one, it refers to basically the total number of protons and neutrons of an element. So when you sum protons and basically neutrons, that total number is the nucleon number or mass number. Let us look at B. A nucleus of uranium-238 decays to form a nucleus of thorium by emission of an alpha particle. State the proton number of an alpha particle, then nucleon number of an alpha particle, then also proton number of thorium and nucleon number of thorium. So we can write a decay equation. So we have basically 238, then U we have 92, then this decays by emitting basically an alpha particle, which is nothing but helium like this. So basically thorium, which we shall call this, will have now, it would have lost 4 particles from the nucleus, so it was going to have 38 minus 4, which is 234. So from this 38 we take out 4, we remain with 234 from 238. Then from 92 we take out 2 protons, we remain with 90. So basically plus energy. So this will be the decomposition equation. So question B1, we need to find the proton number of an alpha particle. So proton number of an alpha particle is basically 2. Then nucleon number, which is the total number of protons and neutrons in helium, is basically 4. Then proton number of thorium, which is 90 after losing 2. Then the nucleon number of thorium is basically 234 after losing 4 particles. 234. So basically this is how you answer this question to get the full 5 marks.